SpaceX wants to build AI data centers in space, but can they survive? Source: The Conversation. What if the next generation of artificial intelligence wasn't powered from Earth at all, but from giant computers orbiting hundreds of kilometers above our heads? It sounds like science fiction. Wow. Massive data centers floating silently through space, powered by endless sunlight, processing unimaginable amounts of information while Earth spins far below. Yet, this futuristic vision is quickly becoming a serious engineering proposal. SpaceX and several other companies are exploring the idea of building AI data centers in orbit, a concept that could transform both the space industry and the future of artificial intelligence. The promise is enormous, but so are the challenges, because building a computer in space is one thing. Keeping it alive, there is something entirely different. Every time you ask an AI a question, stream a movie, save a file to the cloud, or make an online payment, enormous data centers perform billions of calculations behind the scenes. These facilities are among the most energy-hungry structures ever built. Modern AI systems require thousands of specialized processors, consuming massive amounts of electricity while generating tremendous amounts of heat. As AI becomes more powerful, demand for computing power is growing at an unprecedented rate. Across the world, companies are racing to build larger and larger data centers, but they're running into problems. Communities often oppose new facilities because they consume huge amounts of land, water, and electricity. Power grids are reaching their limits. Cooling systems require enormous resources, and the environmental impact continues to grow. So engineers have started asking an extraordinary question. What if we moved the data centers off the planet entirely? At first glance, space seems almost perfect. Unlike Earth, there are no cities competing for land. No neighborhoods complaining about noise. No local power shortages. And perhaps most importantly, there is almost unlimited sunlight. Solar panels in orbit receive far more consistent energy than those on Earth, where clouds, weather, and nighttime constantly interrupt production. An orbital AI facility could theoretically generate clean power almost continuously. For companies building the next generation of artificial intelligence, that idea is incredibly attractive. But then reality enters the picture. Every computer converts electricity into heat, and heat is the enemy of electronics. On Earth, data centers rely on enormous cooling systems filled with fans, pumps, chillers, and sometimes millions of liters of water. In space, however, there is a completely different problem. There is no air, no wind. Nothing to carry heat away. Although outer space is unimaginably cold, nearly minus 270 degrees Celsius, that doesn't automatically cool a spacecraft. Without air, heat can escape only by slowly radiating away as infrared energy. And that process is surprisingly inefficient. Researchers estimate that removing just 10 megawatts of waste heat could require radiator panels covering an area roughly equal to 2 football fields. Those radiators would have to be launched into orbit along with the computers themselves. Power presents another challenge. Even the most advanced solar panels convert only about half of the sunlight that reaches them into electricity. The rest becomes additional heat that must also be removed. And depending on the chosen orbit, Earth itself periodically blocks the sun, forcing systems to rely on batteries or backup power. Designing a stable orbital power system quickly becomes an enormous engineering puzzle. Then there is space itself. Orbit may appear peaceful, but it is one of the harshest environments imaginable. High-energy radiation constantly bombards electronics, gradually damaging computer chips and shortening their lifespan. Tiny micrometeorites travel faster than bullets. Even a fragment only a few millimeters across can puncture a spacecraft, and human-made space debris creates another growing danger. Thousands of satellites already circle Earth, Adding giant orbital data centers increases the risk of collisions that could generate even more dangerous debris. One catastrophic impact could destroy an entire facility. Maintenance creates an even bigger problem. On Earth, replacing a failed server is routine. Technicians simply remove the old hardware and install a new one. But what happens when that server is hundreds of kilometers above the planet? Sending astronauts is extremely expensive. Launching replacement hardware costs millions of dollars. Even robotic servicing systems remain largely experimental. And there's another complication. Computer technology evolves incredibly fast. Most modern data centers upgrade their hardware every 3 to 5 years. New chips become dramatically more powerful and energy efficient. If an orbital data center cannot be upgraded easily, it risks becoming obsolete long before the spacecraft itself reaches the end of its life. Communication presents its own challenge. Every calculation performed in space must eventually exchange information with Earth. That means enormous amounts of data must travel through laser links or radio communications. While satellite networks like Starlink have already demonstrated high-speed communication from orbit, an AI data center would generate data on an entirely different scale. Keeping billions of calculations synchronized between Earth and space would require communication infrastructure unlike anything currently operating. Despite these obstacles, companies continue moving forward. SpaceX has already announced plans for its Ione compute satellite, an early attempt at creating an orbital computing platform. But there is an important reality check. Current concepts remain dramatically smaller than the giant AI data centers operating on Earth. Experts estimate early orbital systems could be anywhere from 100 to 1,000 times less capable than today's terrestrial facilities. So why pursue them at all? Because not every computing task needs to happen close to people. Some applications naturally belong in space. Satellites continuously collect enormous amounts of Earth observation data. Day. Scientific missions generate streams of information that could be processed directly in orbit instead of transmitting everything back to Earth. Military systems, deep space exploration, and future space industries may all benefit from computing resources already located beyond the atmosphere. In that sense, the first customers for space-based AI may not be humans on Earth, but machines already operating in space. Perhaps the most fascinating aspect of this idea is what it represents. For decades, humanity has viewed space primarily as a place to explore. Now it is gradually becoming a place to build infrastructure, power stations, communication networks, manufacturing facilities, and perhaps one day, entire computing ecosystems floating silently above the planet. Whether orbital AI data centers ultimately become practical or remain an ambitious experiment, one thing is already clear. The future of artificial intelligence may not simply depend on building smarter computers. It may depend on deciding where those computers belong. And someday, when you ask an AI a question, the answer might not come from a server hidden inside a warehouse on Earth, but from a silent machine orbiting high above the clouds, powered by nothing more than sunlight and the vacuum